Welcome back again to Echo Wisdom. Today, let's move to solution for combating climate change within decades. Earth is rapidly warming and scientists are developing a variety of approaches to reduce the effects of climate change. The scientist has proposed a novel approach, a solar shield to reduce the amount of sunlight hitting Earth. Let's move to more detail. The paper, Solar Radiation Management with a Tethered Sun Shield, is published in Proceedings of the National Academy of Sciences. The Earth is rapidly warming, and scientists are developing a variety of approaches to reduce the effects of climate change. Istvan Shahpudi, an astronomer at the University of Hawaii Institute for Astronomy, has proposed a novel approach, a solar shield to reduce the amount of sunlight hitting Earth, combined with a tethered, captured asteroid as a counterweight. Engineering studies using this approach could start now to create a workable design that could mitigate climate change within decades. One of the simplest approaches to reducing the global temperature is to shade the Earth from a fraction of the sun's light. This idea, called a solar shield, has been proposed before, but the large amount of weight needed to make a shield massive enough to balance gravitational forces and prevent solar radiation pressure from blowing it away makes even the lightest materials prohibitively expensive. Shahpudi's creative solution consists of two innovations: a tethered counterweight instead of just a massive shield, resulting in making the total mass more than 100 times less, and the use of a captured asteroid as the counterweight to avoid launching most of the mass from Earth. In Hawaii, many use an umbrella to block the sunlight as they walk about during the day. He was thinking, could we do the same for Earth and thereby mitigate the impending catastrophe of climate change? Shahpudi said. Shahpudi began with the goal of reducing solar radiation by 1.7%, an estimate of the amount needed to prevent a catastrophic rise in global temperatures. He found that placing a tethered counterbalance toward the sun could reduce the weight of the shield and counterweight to approximately 3.5 million tons, about 100 times lighter than previous estimates for an untethered shield. While this number is still far beyond current launch capabilities, only 1% of the weight, about 35,000 tons, would be the shield itself, and that is the only part that needs to be launched from Earth. With newer, lighter materials, the mass of the shield can be reduced even further. The remaining 99% of the total mass would be asteroids or lunar dust used as a counterweight. Such a tethered structure would be faster and cheaper to build and deploy than other shield designs. Today's largest rockets can only lift about 50 tons to low Earth orbit, so this approach to solar radiation management would be challenging. Shahpudi's approach brings the idea into the realm of possibility, even with today's technology, whereas prior concepts were completely unachievable. Also, developing a lightweight but strong graphene tether connecting the shield with the counterweight is crucial. Comment on your ideas about this new approach and stay focused on the effects and benefits of this approach. Let's confront new research.